dear students, let's continue our practice on mathematical analysis 1, and today's topic is derivative of a function. Firstly, let's recall the definition of derivative of a function. To give a definition to derivative, you need to give definitions, increment of argument and increment of function. Firstly, what's increment of argument? If we consider any interval, for example here x and this one is x1. So increment of argument, this is delta x, we denote by delta, and delta x it's equals to x1 minus x. This is increment of argument. And now increment of function, it is delta y. So if we consider here function y is f of x, here we need to write increment of function with delta x. So it will be f x plus delta x minus f of x. This is we call increment of function. And the limit as delta x tends to 0, the ratio of increment of function to increment of argument, so it is delta y over delta x. This is derivative of our function, and we denote by this symbol y prime. So this is derivative of function. And now let's move to the main rules of taking derivative. The first one is derivative of constant, it is 0, any constant. And the second one, here, if we consider two derivatives, for example, if we consider sum, f of x plus g of x, derivative of this sum is the sum of derivatives. So it is f prime plus g prime. Or we can write with difference also here. Number 3. Here we will write the constant, for example, c times f of x, and derivative of this one is c times f prime. Or if it is product of two functions, the first one, for example, we have u and v functions, and product of this function is u derivative times v, it is v, plus then u times v derivative. This is rule of taking derivative from product of two functions. And now division, it is, if it is division, so it is u over v derivative. Of course, v is not equal to 0. So here we need to write u derivative times v minus u times v derivative over v squared. So this is main rules of taking derivative. And now here let's move to the table of the derivative. So the table of the derivative, it means the table of elementary functions, derivatives of elementary functions. So the first one, it's power function. We write here c prime, it's 0, this is main one, the constant, if it is constant. And now the next one, power function, it is x the power of n, derivative of this function. What will be the derivative of x the power of n? It is n times x n minus 1. So this is the derivative of this function. And particularly, if we consider x, just x, the derivative of x, now, if you put to this formula, this is x first degree. So, it will be 1 times x, 1 minus 1. So, it is 0. It means we get x to the power of 0. So, x to the power of 0, this is 1. And the answer is just 1. If you consider, for example, x squared, derivative of x squared, it is 2 times x, 2 minus 1. So, it means 2 minus 1, it is 1. So, it's just 2x. And etc. So, this is just power function. Here are some examples. And the third one. So, the next function, this is power function. We can consider trigonometric functions also and logarithmic functions. So, next one is e to the power of x, for example. So, this is e to the power of x, exponential functions. Derivative of e to the power of x, it is e to the power of x, natural logarithm of a. So, next one. Particularly, here we have e to the power of x. If it is e, and now it gets e to the power of x times natural logarithm e. And this is 1. That's why it's just e to the power of x. And now, any trigonometric functions, sine x, it is cosine x. This is table of elementary functions, the table of derivatives of elementary functions. 6 cosine x, it is minus sine x. This is minus sine x. And other ones. So here we have also other table of other functions. For example, we can write here square root of x also. So square root of x, it is just x to the power of 1 over 2. Yeah. If we use this definition, so we can write here just 1 over 2 square root of x. And the next one, tangent x, from trigonometric functions. So here we can write for other trigonometric functions also sinus, sine, cosine, tangent, cotangent, arcsine, arccotangent. Let's write other ones also. So tangent x, it is 1 over cosine square x. And how to get this one, tangent x? For example, let's open this tangent x. Tangent x, it is sine x over cosine x. Yes? Sine x over cosine x. So, we need to take a derivative, find the derivative, tangent x. So here, what should we do? In this case, so sine x, the ratio of sine to cosine, we will use the rule of division, yeah? The basic rule of finding derivative, u over v. It is u prime times v minus u times v prime over v squared. So let's use this one. And then we will get the following one. So here now the sine derivative of sine x times cosine x, the second function, and then minus first function and times derivative of the second function, denominator, over cosine x, denominator squared. Let's continue. So now the derivative of sine x, this is cosine x. The derivative of cosine x, this is minus sine x. So let's use 5 and 6. We have here cosine x times cosine x, and here minus sine x times derivative of cosine x, this is minus sine x again, over cosine x squared, or just cosine squared x. So now we need to get this one, 1 over cosine squared x. So how to get? Look here, cosine squared x minus sine times minus, so it is plus sine squared x equals to cosine squared x plus sine squared x over cosine squared x. Using the main identity of trigonometry, here we get 1 in numerator. So this is just 1 over cosine squared x. Okay, now similarly we can find for cotangent x. It is 1 over minus sine squared x now. You can prove by yourself this one also. Okay, now next ones. For natural logarithm. So here we have just 1 over x. We can find this one by this one, logarithm. If the generally logarithm, the base a x prime derivative. So here we have 1 over x times natural logarithm of a. Natural logarithm of a. And in this case, it will be a here is e, number e. So natural logarithm of e, this is just 1. So that's why it's just 1 over x. Okay, now we have other trigonometric functions. For example, here we have arcsine and arccosine. Okay, let's write them also. Arcsine x, it is 1 over 1 minus x squared. This is for arcsine x. This is for arcsine x, derivative of arcsine x, of course. Arcsine x. And the next one, arccosine x. Similarly, we have derivative of arccosine x. It is minus 1 over 1 minus x squared. And here we have arctangent and arccotangent. So arctangent x, it is 1 over 1 plus x squared. And the arccotangent x, derivative of arccotangent, it is 1 plus b minus x squared. I think this is enough for us now. And let's continue. And now let's consider examples here. So let's begin with algebraic functions. The first example, y is x fifth degree minus 4x cubed plus 2x minus 3. So I choose the examples from the book The Methodology. Here, how can we find the derivative of the function? Find the derivative of the following function. So now we use, in this case, in this example, we use just power function, derivative of power function. And let's recall one more time, x nth degree derivative is n times x n minus 1. Okay, now let's use this one, and y prime, it is x fifth degree. So, and we can use the sum of two functions. The derivative of sum of two, the derivative of sum, it is sum of derivatives, u prime plus v prime. Let's use these two ones, and we get the next one, y prime. It is, we can find each ones in polynomial separately. For x fifth degree, it is 5 times x, using this one, 5 minus 1. Then it is x. Next one, minus 4 times 3, the power, times x 3 minus 1. And the next one, plus 2 times x 1 minus 1. And the here we have just 0, because the derivative of the constant, it is 0. So if we continue, here we have 5x fourth degree minus 12x second degree plus 2, just because here x1 minus 1 and 0 power, and 0. So this is answer of our example. This is derivative of our function. Okay, now, if it's clear, let's move to the next example. So now I will not write every time this table. I think it's clear. Next one. The next one is, let's consider the next one, y, it is x squared times cubic root of x squared. Yes. So, how to find in this case? So here we can write this x squared inside of this cubic root, and it will be cubic root of x squared times x sixth degree. Yes? Because we need to multiply it by 3. And now we have here cubic root of x 8th power, or just x 8 over 3, the power of 8 over 3. And now let's use one more time the derivative of the power function. So here we have x 8 over 3, derivative of this one. Let's write y prime, it is this one, 8 over 3 prime, or, so, continue, y 8 over 3 times x, the power of 8 over 3 minus 1. And now, let's continue, 8 over 3 times x, if we subtract 1, 5 over 3. And now we can write as, it is 8 over 3 times 5th degree root, cubic root, x, the power of 5. And now, let's consider the next example. Okay, for example, y, it's the function of 2x plus 3 over x squared minus 5x plus 5. And now here we will use the derivative of the division, so the rule of derivative of the division. So here we have y prime, it is 2x plus 3 prime times x squared minus 5x plus 5 minus the first function 2x plus 3 times the second function, derivative of the second function, x squared minus 5x plus 5 prime over the square of this denominator. Okay, let's continue. We have just 2, because the derivative of this, the first one is 2, times x squared minus 5x plus 5, and then minus 2x plus 3 times, here, the derivative of this function is, the first one is 2x, the next one is minus 5, over x squared minus 5x plus 5 squared. Okay, if we continue, here we get the denominator will not change, x squared minus 5x plus 5 squared, and numerator, it's just 2x squared minus 10x. We need to simplify this expression and get the final answer. Plus 10. Here we have minus 4x squared minus plus 10x minus 6x and plus 15. Okay, let's continue. So the final one is, after simplifying, it is x squared minus 5x plus 5 squared, and top is 2x squared minus 4x squared. This is minus 2x squared minus 10x plus 10, they are cancelled, and we have just minus 6x and minus 6x, I think, and the last one is the free term, it is 10 plus 15, so 25 it is, plus 25. This is answer of our example. Okay, next one now. The next example is derivative of trigonometric functions now. So here y is equals to, for example, 5 sine x plus 3 cosine x. Okay, now the derivative of this function is 5 times sine x, derivative of the sine x, plus 3 times derivative of cosine x, because this is constant, they are constants. And now, if you continue, so derivative of sine x, this is just cosine x. Okay, 5 cosine x plus derivative of cosine x, it is minus sine x. That's why here now in the middle it will be now minus 3 sine x. The next example. Okay, so y is x times cotangent x. How can we find the derivative of this function? Here we need to use the basic rule of finding derivative of product of two functions. And let's use this rule, and we get here y prime, it is the derivative of the first function times second function, cotangent x here, and then here plus the first function times the derivative of the second function. Okay, now the derivative of the first function x, it is just 1 times cotangent x, so it is cotangent x, and plus x, the derivative of the cotangent x, the second function, is minus 1 over sine squared x. So in the middle we have minus now, because the derivative of this one is minus 1 over sine squared x. Let's put it to the instead of cotangent x, and we get minus x over sine squared x. And we get the answer. Okay, let's continue. And one more function. So let's find for 1 plus x squared times arc tangent x minus x over 2. And let's find derivative of this function. Okay. So y prime here, it is, let's use again the rule product of two functions here in top, and then we need to subtract. So here it's just 2, yes, just 2, yeah. We can write just 1 over 2 times this one, 1 over 2. And here the 1 plus x squared times arc tangent x minus x prime. Let's continue. So now, if we continue, here we have 1 over 2. Now, the derivative of the product. So it is 1 plus x squared, derivative of this function, times arc tangent x, plus the first function times the derivative of the second function. And now minus. So here we have derivative of the sum of two functions, or difference we can say, yeah. So here derivative of this one minus derivative of this one, x. So here minus derivative of x, and we get here 1 over 2. The derivative of 1 plus x squared, it is 0 plus 2x. So it's just 2x. 2x times arc tangent x. And the next one, plus 1 plus x squared, and derivative of arctangent x, it was 1 over 1 plus x squared. So 1 over 1 plus x squared here you need to write. They are cancelled. Here x squared, and here multiplication we have. Sorry, here multiplication we have. And in this case they are cancelled. This is with this one. And we have minus x prime, it is just 1. So the answer is 1 over 2, right, by another color. 1 over 2, here we have 2, and of course here we have 1 from this one. It is 1. 1 minus 1, it is 0. So we have just these ones, these ones. This one times this one. So 2 and 2 are cancelled. And we get just x times arctangent x. This is answer. Okay, I think it's clear. Now let's continue our examples. So the next example, which one we will do? Okay, let's move to the next section. It is exponential and logarithmic functions. And here, for example, let's consider this one. Why this function? X 7th degree times e to the power of x. Okay, here also we need to use the rule of the derivative of product. So in this case, it is the derivative of this first function times second function plus the first function times second function derivative of the second function. And if you continue, x 7th degree, derivative of x 7th degree, it is 7 times x 7 minus 1, so it is 6 power, times e to the power of x, plus x 7th times derivative of the e to the power of x. Let's recall the table of derivatives of elementary functions. It is e to the power of x. So it is simplify our expression. It is, or just we can factorize it. E to the power of x, 7x6 plus x 7th power. This is derivative of this given function. Okay, now the next example, which one? Let's consider this one. E to the power of x times arc sine x. I think it's also clear. It is seen with this one here. Just instead of our 7 x 7th power, we have arc sine x. Yeah, and it's also the derivative of product of two functions. Easily we can write here y prime. It is e to the power of x, because the first derivative of the e to the power of x is again e to the power of x. Arc sine x arcsine x, and plus the next one, e to the power of x times arcsine x, the derivative of arcsine x, it's 1 over square root of 1 minus x squared. Recall again the table. So here we have just these functions, and we can factorize e to the power of x, take out the brackets, and have arcsine x plus 1 over 1 minus square root of 1 minus x squared. I think it's also clear. Okay, now let's move to the next example. Here we have the following one. Y, it is x squared over natural logarithm of x. And let's solve this example. Find derivative of this function. So it is, we can write here, using the rule of derivative of division. So here we have x squared derivative of the first function times the denominator minus first function times the derivative of the denominator over square root of denominator ln squared x. Okay, now let's open this ones, and we have derivative of x squared, it is, yes, 2x times natural logarithm of x minus x squared, and derivative of natural logarithm of x. Let's again recall our table. We have 1 over x. It's equals to 1 over x. So it is 1 over x here. And divide to natural logarithm square root of x. Continue. 2x times natural logarithm of x minus just x over natural logarithm squared x. This is derivative of our given function. Okay, now let's consider the next example. So we have hyperbolic functions. It is hyperbolic sine and derivative of hyperbolic sine x. This is hyperbolic cosine. Derivative of hyperbolic sine, it is hyperbolic cosine. And similarly, we can write for cosine, hyperbolic cosine also. Cosine, hyperbolic cosine x, it is sine x just. Hyperbolic sine x. And now, using these ones, we have the following one. Y x squared over hyperbolic cosine x. So here again we can use the ratio, so the derivative of the ratio and division, and find this one. I think it's also clear, and you can, so the derivative of hyperbolic cosine x, this is just hyperbolic sine x, and you can do by yourself this example. Now let's move to the next section. So this is next section is just a second. Composite functions we have now. So here we have composite functions. So for example, which one? Let's do, for example, this one. Y, it is 3 plus 2x squared, fourth degree. This example. Let's consider this example and find derivative of this function. Here we have the rule for composite functions. The derivative of function fg of x, the derivative of this function, it is the derivative of first function, f derivative of g of x, it's just like argument in this case, the next function, and times we need to multiply to the derivative of this second function also. So it is g derivative of x. So this is rule for composite functions. Let's give firstly a simple example. So, for example, y it is e the power of 3x, for example. This is also composite function because here we have the first function, it is e the power of x. The second function it is the second function it is 3x. So e the power of 3x. So that's why the derivative of this function is e the power of first function. Derivative of the first function, it's just like this, 3x derivative times 3x derivative also. Like this, we need to find it. And here we have, for example, in this case, e the power of, 3x, it is just argument of this function. Like this, just e the power of 3x it will be, because this is first function. And you need to consider it, so like composite functions too. Here we have just e the power of 3x, because the derivative of the e the power, it is e the power of x, it's e the power of x, and times 3x derivative, it is just 3. So answer is 3 e the power of 3x. If we return to our example, here we have firstly, let's find, so it is, let's write one more time, y 3 plus 2x squared, fourth degree. Okay, firstly, here we have power function, and inside we have the next function. We can do this example by finding fourth power of this polynomial, and then after this one find derivative for each terms of this polynomial. Yes, of course we can do it, but it takes time. So we need to if we use our rule for composite functions, this is very easy. So here we have the first function, it is, I said, power function. The second function, this one is. So now let's take the derivative from this power function. Firstly, it is 3 plus 2x squared. Yes. And time the power of 4 minus 1. This is power function. X the power of n times x n minus first degree. Here also the same. 4, this is just x like, our x now. But our x, our argument, this is function. This is not just x, it's function. That's why we need to use composite functions, rule of composite functions. So, and then multiply by g prime x. Yes? If you recall, f prime g x times g prime x. Okay, now g prime x, it is 3 plus 2x second prime. Okay, so now it is 3 plus 2x squared cubed times, here we have just sum of two functions now. And we get here 0 plus 2x squared. It is the prime of this one is 2 times 2x 1. Yes? So it is 4x just. It's just 4x. This is derivative of given function. We can simplify. It's 16x 3 plus 2x squared cubed. Okay, this is for composite functions. And now, next example. So, the next function, it is 1 minus x squared. 1 minus x squared here x squared. So, here again, we have square root function. This is main one. And in the inside, we have this second function also, 1 minus x squared. So now, firstly, we need to use derivative for square root, and then for this function, which is in the inside of our function. Okay, this is g. And square root, this is f. Okay, now, let's find derivative of this function. It is, let's recall again, from table, square root of x, it is 1 over 2 square root of x. So, 1 over 2 square root of this function, 1 minus x squared. And times, and derivative of this one, 1 minus x squared. Derivative of this one. Okay? If you continue, here we have 1 over 2, 1 minus x squared times 1 minus x squared. Derivative of this one, it is 0 minus 2x. So the answer is minus, if you multiply, here we have minus 2x. This is answer. This is solution. Okay. I think it's clear with composite functions. So again, one more time, I will remind you. So if we find the derivative of two composite functions, f and g, here we need to take this g of x in first case as argument of the first function and find derivative of f with argument g, and then multiply to the derivative of this argument also, because it also depends on x. This argument, this gx also depends on x. That's why we need to consider the derivative of this function also. Okay. Let's continue. So the next example is for example y, it is 2x plus 5 cosine squared. Let's change our example. Does cosine squared do more difficult? 3x, for example, not just x, 3x. And here also, for example, 2x, the 2x fifth degree, for example. Okay, find the derivative of this function. It is 2x fifth degree, it is 10x fourth, yes, using the power function, derivative of the power function. Then, here we have, look here now, 5 cosine squared 3x. So here we have function, the main function it is, in this case now, squared, power. Then we have cosine. And then we have this 3x. So, one more time. The main one is this one, power. The next one is cosine. And the next one is, it is 3x. It is 3x. So, we have composition of 3 functions, can say. So now let's begin with the main one, with the black one. So it is power function 2. Here we have 2 times 5 cosine, and now 2 minus first degree. It is first degree. Just cosine 3x, and now the here we have the derivative of this one now. The derivative of the first argument. This is cosine 3x. Cosine 3x derivative. Okay, now we have 10x fourth plus 10 cosine 3x times now. And now when we find the derivative of cosine 3x, here we have again these two functions now, blue one and green one, yeah? So here we have cosine x and 3x. So it is cosine, the derivative of cosine is minus sine 3x times 3x derivative. Clear? So 3x derivative. If we continue, here we have 10x fourth power plus 10 cosine 3x. Just write minus, because here we have minus. In the middle it will be minus now. Minus. And now sine 3x times, we get here just 3. Because the derivative of 3x, it is 3. Okay, so here we have 10x fourth power minus now 30 with this one, cosine 3x, and here let's consider this one, cosine 3x sine 3x, using the trigonometric formula. So here we have sine 6x, yeah. If you multiply by 2, it is sine 6x. Now it is not 30. Divided by 2, it is 15. 15 sine 6x. This is final answer. One more example. Here we have another examples. For example, okay, just 1y 1 over arctangent x. 1 over arctangent x. So here the first function it is 1 over x. The next function it is arctangent x. Okay, firstly, what will be the derivative of 1 over x? It is if we consider it's like a ratio of this 1, so 1 over x, it is minus 1 over x squared after using the rule of the ratio. So now here we have y derivative in our example. Y derivative is minus, let's use this one, yeah? Because as x we have arctangent x here. And then we need to multiply to derivative of the arctangent x also. So here we have arctangent x squared with minus, yeah. So times arctangent x, derivative of arctangent x. Let's continue. We get minus 1 over arctangent x squared, of course, and here minus we have. And the derivative of arctangent x, it is 1 over 1 plus x squared. Plus x squared. If we multiply these two functions, we get the answer. I think the examples are clear for you, and we'll stop here our today's lesson, and the next time we'll continue the topic derivative and differentiation. Thank you for attention.